In this section, we'll perform a second overlay and also integrate Manifold with Microsoft Excel in order to perform some accuracy assessment of the data that was digitized. You should already have your land cover drawing in your current project. If you don't, load it now and color code it based upon the colors that I have here for agriculture, developed, extractive, forest, water. Now we can create a new map, and we'll have the land component inside it. Are you getting tired of recoloring the map each time for each of our lessons? There's really an easy way to avoid it. To do it, what we're going to do is we're going to select the area background button that you normally use to color the map. But this time select Theme, and now go into the File Open folder. And here we have a file called theme.xml. And that's a file that's already defined the colors for you. Once you set the colors the way you want it, you can also save the cartographic representation as an XML file as well. Okay, the next thing we're going to do is open up Microsoft Excel. And we're going to add a file called FieldCheck84XLS. That should be under your data directory. There are 201 records, and the top column includes all the field names. Those field names will represent the actual code, the latitude, and the longitude values. These represent 201 field verified points. Let's go back into Manifold, and we're going to import an Excel drawing. So go to File, Import Drawing, and change the file type to Excel. Open up the FieldCheck WGS84, and you'll see that Manifold recognizes the Excel layout. It automatically recognizes the latitude and longitude and the code field. We'll stick with the defaults here and load the file. Once the file is loaded in the project pane, we can actually drop it into the map, but let's rename it first to GPS. That's just going to make things easier for later. And now drag and drop GPS into our map component, and you'll see the GPS points laying on top of the land cover. Now let's change the thematic rendering of the points by selecting the point background, and then we'll select Theme. Now here let's go and select the Open button, and we're going to bring that theme value back in. And we're going to use the same codes. And here you can see some of the places where we said we had forest and actually were forest, or where we said it was developed and actually is developed. We can also see we've got some forest where we thought there's some agriculture. So there's some errors on this map. Let's create a new query and perform some accuracy assessment. Now I'm going to create a rather long query that you can evaluate a little later. But take some time, pause your video, and actually type in this command. What we're doing is we're going to create a pivot table where we select the land cover from the map that we made, and we compare that to the land cover from the GPS derived points. So this is classic SQL, except we're also using a contains clause, which is a spatial operator. So we're trying to find only those points that intersect the polygons, and we're grouping it by the land cover. And what this will do is create a pivot table or a cross-tabulation matrix. And as we run the query, you can see along the diagonal are those areas where we thought it was A, and the field check said it was A, or we thought it was D, and the field check said it was D. Now there are some cases where we thought it was agriculture, but the field check actually showed that it was developed, so those were interpreted incorrectly. So now we're going to create a second query so that we can throw the results of that first query into an actual table. The first one really only created a virtual table, so we're going to just select everything into a new table. We'll call it ACC table from query. So what this will do is runs the query and creates a new table. So here's our cross-tabulation matrix. Under Edit, let's select all the values and then go and copy those values. Return now to Microsoft Excel and let's just create a new project. And here I'm going to paste the table so you can see Manifold integrates pretty well with Excel. Well, I'm going to create a formula over here along the diagonal that just adds up all the diagonal values. And this is basically saying for all those 201 points that we found, how many actually match what we put on the map. We'll create another formula underneath it that just sums up all the area, which is 201. And then we'll look at our accuracy, where we'll divide the total number we had correct based on the total number of points. And here you see that my accuracy is about 75%.